Okay, so we have been working with linear equations. Now we are going back to linear inequalities because, yes, eventually we will be working with systems of inequalities. So, with that being said, think back to an inequality, hoping that you remember there are several solutions. So, in this case, we will use one of the inequality symbols. And you have to remember that all ordered pairs are going to be solutions now. Not all ordered pairs, let me rephrase that. You're going to say the solutions in an ordered pair format. There we go. Okay, so what is a linear inequality? Well, it is similar to a linear equation. It's going to form some type of line, but it has an inequality symbol. Less than, greater than, less than or equal to, greater than or equal to. Those are all going to be your symbols. Okay, so what is a solution? This is what I was trying to say before, so I'm really sorry. So your solution will be any ordered pair that makes the inequality true. All ordered pairs, x comma y, that make the inequality true. Okay, so we will go through what makes it true. This is page 76 to keep your notebook in order. Again, if you need a new notebook, you got to get one. Okay. Okay, so first example, we are going to work with this linear inequality. There's a couple ways that you could solve this. You could, yes, I know a lot of you are going to want to use your graphing calculator, but before you do that, please pause. Okay, don't jump to the calculator. So what you're going to do is you're going to use your x and y values and you're going to plug them in. Essentially, you're evaluating. So I'm specifically telling you that your x is 2 and that your y is 5. And I'm trying to determine if they will be less than 15. So we have your 4 minus 15. 4 minus 15 is negative 11. Is negative 11 less than 15? Yes, it is. This is a solution. Okay, so same inequality. We're going to plug in our x and y. Just watch out for the negatives. 2 times negative 1 minus 3 times negative 7. We're determining if it's less than 15. Negative 2 minus negative 21. And hopefully you recognize that a negative next to a negative turns into a positive. So we have negative 2 plus 21 is that less than 15. And 19 is less than 15. That is not true. So we would say no. Okay. Next one, I'm going to change colors just because my boxes are getting close together. All right, so we have 2 times 3 minus 3 times negative 4. Is that less than 15? 6 minus a negative 12. Or if you want, you can go ahead and just change that to a plus. 6 plus 12, that is 18. 18 is not less than 15, so our answer would be no. All right, switch it one more time. All right, 0, 2 times 0, minus 3 times 0, is that less than 15? And yes, it is. Alrighty. So yeah. So graphing calculator, if you type that equation in, if you type that inequality in and you find these ordered pairs and it's in the shaded part. So that's the part that I'm going to talk about now. Okay, so you can plug and chug. So this is your evaluation. So if I tell you to evaluate, this is your strategy. Okay, I'm giving you the variables, you plug it in, you solve it just like you would. All right, now when you are graphing, okay, how do I show this? And this is what I mean by anything that's in the shaded part. So just like we did on the number line, anything that is shaded or covered is going to be a solution. Now, again, you know that this is going to have to be the case, so you have to make sure that it is written in slope-intercept form. Hopefully I don't have to tell you what that means, but y equals mx plus b is what I am referring to. So, steps for graphing. Step 1, write the inequality in y-intercept form. So, in this case, your equal sign will turn into your inequality. How do I know? Okay, so remember before when we were graphing inequalities in 6th grade, you just learned how to use these symbols. So if you have a less than or greater than, you're going to have a dash line. And I'll explain what that is in a second. And then if you have a greater than, less than or equal to, or greater than or equal to, your line is going to be a solid line. Okay. And you know, with math, we like to confirm. So we are going to use a test point. Typically, most people stick with 0, 0. Why? Because it's easy to work with. And then if that is the case, that will tell you which side it goes on. So if you notice right here with your line, this is actually a solid line. And if I were to pick 0, 0 in here, you would tell me it's a solution because that is in that shaded part. So any ordered pair over here in the shaded and on the actual line, because it's solid, it's included. So this is a solution, and anything shaded is a solution. So as a little reminder down here, all the points within the shaded region represent a solution. Okay, so less than or equal to, greater than or equal to, any shaded region are considered the solution. Okay, so of course, you know we're going to have some practice. So we're just sticking with just one inequality on the graph, okay? So you can easily graph this. A lot of you are smart. You don't even need your graphing calculator because I know a lot of you are going to jump to it. So this line right here, this has a greater than. There is no line under it. We're going to have a dotted line or a dashed, whichever one you prefer to call. Okay, so we have y is greater than 1/3 x minus 5. So a couple things. You can plot that or you can plug in. So if you look at this, you're 1/3 negative 5. So we're going to start at negative 5. 1, 2, 3, 4, 5 because that's my y-intercept. And my slope is up 1 over 3. Up 1, 1, 2, 3 over 3. 1, 2, 3. So my slope is not very steep. So if I was to keep going, this is what it would look like. But it's not going to be a solid line. Okay. And then in this case, I'm going to pick 0, 0. I'm going to see which side I shade. So I'm going to plug in 0 for y and 0 for x and see if it's true. So 1/3 times 0 is 0. 0 minus 5 is negative 5. Is that true? Yes, it is. So I'm going to shade over here. Okay. Now, the shading is important. So if you want, you can use colored pencils because then you can really see the overlap. Markers tend to get a little crazy, but I just want to make sure that you see what I'm working with here. Okay. All right. I'm going to give you, I'll do a couple other examples. So maybe if I do the first 4, no, I'm going to do 1, 3, 5, and 7. I think you can handle the other side because, again, I think it goes side by side to help you convert. So both y-intercept form, and the only difference is this has a line under, so it's going to have a solid line. This one right here is going to have a dashed, dotted, solid, so just kind of pay attention. All right, so the problem with this one is it's not in y equals mx plus b format, so you have to get it in that format. So I'm going to subtract 5x from both sides, and then I'm going to divide by -2. And when we divide by a negative number, if you remember, we have to flip our symbol. I know, that wasn't fun. So our y equals is y less than 5 halves is our slope, x minus 6. So I'm going to pick an order pair of 0, 0, and I'm going to determine which side. So once I plot this, so 1, 2, 3, 4, 5, 6, up 5 over 2, 1, 2, 3, 4, 5 over 2, 1, 2, 3, 4, 5 over 2. Okay, and we said this was a dotted line, dashed. Okay, so if I plug in 0, 0, 0 is less than 5 halves, 0. So 0 is less than -6. That is not true. So I'm going to shade on the other side. Because this point right here was not a solution, so then you go to the other side and shade. Okay, so 4, work on 4. It will help you with 3, or 3 will help you with 4. There we go. All right, and then number 5 and 6 are similar to 3 and 4. Okay, so convert them to your y equals mx plus b format. And I'm going to talk about 7 and 8 because I feel like a lot of you struggle with these. So again, when I tell you that y is less than or equal to -4, I'm telling you that every single number is going to be, for y specifically, is going to be less than 4 or equal to -4. So if I plug in my 0, is 0 less than or equal to -4? And you would tell me no. So because it is not less than, I'm going to shade the other way. So your line would look like this. So you would have 1, 2, 3, 4. It's going to be a solid line straight across because of this symbol right here. That means a solid line. And I'm going to shade over here because according to what we just determined is 0, 0 is not a solution. So that means everything on the other side of the line is going to be it. Okay, so again, y is less than or equal to -4. You're going to treat it similar to this. However, instead of having a 0 line, you are going to have an undefined line. So it's going to be a vertical. Okay. All right. Questions if you have some, please see me, pause it, rewind it, watch it, all that good stuff. All right. Thank you.